Have you ever, like, peered into your Linux desktop and just wondered what really makes that whole visual experience work? Or maybe why there seem to be, I don't know, a dozen different ways to install software?
Right.
It's really so much more than just an operating system, isn't it? It feels like a whole universe of choices, often kind of hidden beneath the surface. So today, we're doing a deep dive into the GNU Linux desktop. We want to pull out the core components, the essential skills that, well, really anyone curious about these systems, especially if you manage them, should probably know.
Yeah, that's exactly right. Our mission here for this deep dive is basically to give you a shortcut, a way to get genuinely well-informed about the GNU Linux desktop without, wading through everything yourself.
Okay.
We've looked at a really comprehensive guide focusing on critical desktop skills and technologies, particularly for sysadmins.
Right.
So we're going to cover, well, everything from the basic display systems and audio frameworks through to the different desktop environments, how apps are managed, security stuff, which is crucial, and even remote access.
So it's not just the what, but the why.
Exactly.
Yeah.
Not just what these things are, but why they actually matter for, practical day-to-day use.
All right. Sounds good. Let's start unpacking that foundation then. The stuff you interact with every single time you sit down, the display. You've probably heard names like Wayland and X11 thrown around.
The classics.
X11, the X window system. I mean, that's been the workhorse for decades, right? A real veteran,
Wow.
known for its network design, which back in the day gave it amazing flexibility for remote display.
True.
But, well, for all that power, it also came with a lot of legacy baggage. It felt complex, maybe a bit dated, especially on the security front for modern stuff.
And that's really where Wayland comes in. It's the modern replacement, designed from the ground up to be simpler, more direct. It cuts out a lot of that X11 overhead.
Okay, so what are the benefits then, like for the user?
Well, the immediate things you notice are better performance, smoother graphics, definitely a big step up in security, which is huge, and lower input latency. Things just feel snappier, more responsive.
So, okay, for someone listening, maybe managing a desktop or just trying to get their own system running smoothly, how do you choose? Is X11 still needed sometimes, even with Wayland sounding better?
That's a really critical question. Wayland is definitely becoming the modern default. You see it in GNU, other places. For just everyday local desktop use, it's generally the better pick. Security, performance, it's all there. But X11 isn't totally gone yet. It's still relevant for some, let's say, legacy apps that haven't quite made the jump. Or maybe for very specific advanced remote desktop scenarios where that old network-based design of X11 still offers something unique.
Oh, okay.
So understanding that difference is really key if you're troubleshooting display problems or trying to optimize a specific setup. Got it. And speaking of optimizing, let's talk sound and video. Because anyone who's wrestled with Linux audio in the past, it often felt a bit like a Frankenstein's monster situation, right? Trying to stitch things together.
This light laugh. Yeah, you definitely hit the nail on the head there. PulseAudio was, okay for general desktop sound, but it kind of struggled with low latency pro audio stuff.
Right, and then there was JC.
JACK Audio Connection Kit, fantastic for professional, super low latency needs, but boy, it could be complex to set up, a real headache sometimes.
So this sound server limbo, as you called it.
Yeah, that was a big pain point.
Yep.
And that's precisely where PipeWire steps in. It's designed as a true unifier.
Unifier, how so?
Well, it's built to handle both your everyday consumer audio and those demanding pro audio requirements all in one system.
Okay.
What's really cool is its low latency support, it handles video capture smoothly, and crucially, it has great compatibility with the older APIs. So lots of apps built for PulseAudio or JACK just fought work. No fuss. So here's where it gets really interesting for you, the listener. PipeWire isn't just some new standard. It's fundamentally changing how multimedia works on Linux. If you've ever fought with audio latency or video capture just not working right, the unification PipeWire offers is, well, it's kind of a revelation.
It really is.
Knowing this is super important for troubleshooting multimedia issues or just setting up new gear. And if you need to dig deeper, tools like Pactal and PuCli, these command line tools.
Yeah, those are your friends.
They become like your dashboard, right? For checking audio streams, quickly rerouting sound, super useful for fixing mic problems or making sure an app uses the right speaker.
Absolutely. Essential tools for diagnostics.
Okay, so we've kind of laid the technical groundwork, what's under the hood.
Yeah.
But where does all that really come alive for the user, or for you, the admin, who might need to craft a specific kind of experience?
Right. That brings us squarely to the desktop environment itself, your graphical home.
Exactly. It's where the rubber meets the road. And picking the right one can totally shape your whole Linux experience. Let's start with GNOME.
GNOME, GNU Network Object Model Environment.
Yeah.
Often the default, you see it a lot in enterprise settings.
Why enterprise?
Its whole philosophy is about a clean, simple, efficient user experience. It really focuses on stability and security. So it's a very reliable choice where you need consistency across maybe hundreds or thousands of machines.
And using it feels pretty straightforward. You've got the activities overview, the app grid, system settings, terminal, file manager, the usual suspects. For tweaking things, there's GNOME Tweaks, that graphical tool for themes, fonts, window stuff.
Right, the easy stuff.
But for the deeper control, there's dconf-editor. That lets you get right into the configuration database underneath.
Yeah, that's for the serious tweaking. And like our source points out, it integrates really nicely with the modern bits we just talked about, like Wayland and PipeWire.
So mastering GNOME, it's not just about clicking buttons, is it?
Not at all. It's about using its predictable, secure foundation to build scalable, consistent environments. For an administrator, that means fewer support calls about weird user configs. It could be a real set-it-and-forget-it kind of deal for big deployments where consistency is king.
Okay, so if GNOME is the stable, consistent enterprise choice, then KDE Plasma is kind of the other side of the coin, the customizable powerhouse.
That's a good way to put it, yeah. KDE Plasma is for users who really want fine-grained control, who want to personalize everything. Our source mentioned its wide range of options for personalizing every aspect.
Like what kind of things?
Oh, wow. Virtual desktops, activities for organizing workflows, widgets you can stick anywhere on the screen for info, and the Dolphin File Manager, which is incredibly powerful. Not just files, but advanced stuff, network share integration. It's really packed.
And they have their own apps too, right? Like Kden Live.
Exactly. Kden Live for video editing, which is very capable. Console, their terminal emulator, is fantastic too. Advanced tabs, profiles, lots of features for command line users.
And for the real power user, the automation.
Oh, yeah. You can customize keyboard shortcuts like crazy, automate tasks using Kalen scripts, fine-tune window management rules. You can really make the desktop behave exactly how you want it to.
So if your job involves supporting users who demand that level of customization, or maybe you need to set up really specialized desktops for specific tasks,
then KDE Plasma is absolutely vital. You need to know it. Its flexibility is just, well, unmatched in many ways.
But okay, what if you're not dealing with power users or high-end machines? What if you got older hardware or VMs, or you just need peak efficiency? Maximize performance.
Right. That's where the lightweight desktops come into play. And this really shows a key part of the Linux philosophy, doesn't it? How much can you strip down an environment but still keep it useful?
Yeah. So like XSys.
XSys, exactly. Xform's common environment. It's simple, it's fast, has a very traditional layout, very, very light on resources, perfect for breathing life into older machines or for systems where you just don't have much processing power to spare.
And then there's LXQT.
LXQT, yeah. Lightweight Qt desktop environment. That one has a bit more of a modern look and feel, built with the Qt toolkit, but it's still incredibly efficient. Designed for really minimal installs where every megabyte of RAM counts.
So these lightweight options, they're perfect for those resource-constrained situations. VMs, older boxes.
Absolutely ideal. They let you get the most usability and efficiency possible without sacrificing key functions. It's invaluable for extending hardware life or running multiple test environments smoothly. Really shows off that GNU Linux flexibility.
Okay, cool. Let's shift gears a bit. Let's talk practical skills. Managing, hardening your desktop, and I guess for any sysadmin, maybe the starting point is virtual machine management, your sandbox for success, as the source puts it.
Small chuckle. Yeah, absolutely. Cool. I mean, who hasn't accidentally broken something important when trying out a new setting or some script they found online? VMs are basically the ultimate undo button for playing around. What's really vital is how they give you these flexible, safe, isolated places for testing, development, training. Yeah. all without touching your real production systems.
And the tools are pretty accessible now, right? VirtualBox, GNU boxes, Virt Manager.
Exactly. They make it relatively easy to get started.
So for you listening, the key skills here are things like creating VMs from ISO images, carefully assigning resources, CPU, memory, storage, installing different desktops inside them, and really getting familiar with snapshotting.
Oh yeah, snapshots are lifesavers. Capture a working state, try something risky, and if it blows up, just roll back.
And understanding the networking too, right? Bridged versus NAT.
Fundamental. Knowing whether your VM needs direct network access like a real machine, bridged, or just simple internet access through the host, NAT.
So looking bigger picture, VMs are just invaluable. Safe experiments, testing software thoroughly, building little isolated labs for learning or training.
It's a core part of the toolkit, absolutely.
Right.
For any admin.
Okay, building on that. What happens when a system outside that safe VM sandbox has a major problem? Or you just need to look at it without changing anything?
Ah, right. That's where your ultimate troubleshooting kit comes in. Live media, portable environments.
Live media. So like a bootable USB stick.
Exactly. Or a DVD, though
Yeah.
USB is more common now. It runs a full GNU Linux environment right from the stick without installing anything to the hard drive.
How's that useful?
It means you can boot up a troubled machine, get access to all the standard Linux tools, disk utilities, file managers, terminal, and basically poke around the installed system without actually running the installed system.
Oh, I see. So for troubleshooting.
It's a lifesaver. You can inspect disk partitions, try to repair corrupted file systems, maybe copy important data off a drive that won't boot anymore.
Okay.
It's also great for just testing hardware compatibility before you commit to an install, or even demonstrating software without having to install it first.
And the tools to make these. Like DD.
DD is the classic command line tool for writing an ISO image directly to a USB drive. Works great, but you got to be careful with it.
Right. And there are others, like Ventoy.
Yeah, utilities like Ventoy are really neat. They let you put multiple different ISO files onto a single USB drive and then choose which one to boot when you start up. Makes your troubleshooting stick even more versatile.
So the key takeaway here is just how powerful and non-invasive live media is.
Totally. It's a foundational technique for system recovery, testing, demos. Really a must-have in any admin's emergency kit.
Okay, let's switch to something people deal with constantly. Application management. Installing software. The Linux desktop has really evolved here, hasn't it? It feels like there are loads of choices now.
Oh, absolutely. You still have the bedrock, the traditional package managers like DNF for Fedora-based systems and APT for Debian Ubuntu-based systems.
Right, those are the foundation. System-wide installs from official repositories, keeping things compatible and stable.
Exactly. But what's fascinating is how the ecosystem has grown beyond that. We now have these modern, often sandboxed formats.
These like Flatpak.
Flatpak, yeah. That provides apps in their own isolated environment. You often get it from repositories like FlatHub. The big emphasis there is security through isolation. Keep the app contained.
Okay. And Snap is similar.
Snap is similar in concept, yes. Also sandboxed, often features automatic updates and ties into the Snap Store. Canonical pushes it quite a bit.
And then there's AppImage, which seems different.
Image is unique, yeah. It's basically a single, portable, self-contained executable file. You download it, make it executable, and just run it. No installation needed.
Huh. So you can just carry it on a USB stick or something.
Pretty much. Perfect for trying out an app quickly or for situations where you can't or don't want to install something system-wide.
So for you, the user or admin, it's really about understanding the trade-offs here, isn't it?
Exactly. Traditional packages give you that deep system integration, that known stability. Flatpak and Snap offer potentially better security via sandboxing and easier cross-distro installs, but maybe less integration sometimes. AppImage gives you ultimate portability.
So you really need to know about all of them.
To be effective, yeah. You need to know how to manage software using all these methods because you'll encounter them all. It's about picking the right tool for the job in different situations.
Okay, finally, let's talk customization and, importantly, hardening. Making the desktop secure and controlled. Why is this so critical, especially for admins?
Well, it really boils down to maintaining security, ensuring consistency, and keeping things usable, particularly across a whole fleet of desktops in an organization.
Right, control.
Exactly. Tools like GNU tweaks, we mentioned that earlier, give you the graphical way to adjust common advanced settings, themes, fonts, window behavior, easy stuff.
But for the serious control.
For deeper, more systemic control, you go back to dconf-editor. Direct access to that underlying configuration database.
And what can you do there?
You can disable specific features entirely, tweak security-related settings, even lock down certain settings so users can't change them. Really helps enforce standards and maintain a secure posture.
And what about kiosk mode? That sounds intense.
Kiosk mode is a powerful technique.
Yeah.
It's for locking down a system so it can only do one specific thing. Think of like a point-of-sale terminal in a shop, or a public info kiosk in a library, or maybe a dedicated workstation on a factory floor.
So you restrict what apps can run, disable parts of the interface.
Exactly. You strip it down and lock it up so it only serves its intended function, and users can't easily mess with it or access other parts of the system.
So the strategic point here is that these tools, tweaks, dconf-editor, kiosk mode, they let you create these really controlled desktop environments.
That's right. Environments that meet both usability needs and strict security standards. It's essential for good system manageability, especially where things like compliance or just predictability are really important.
Okay, let's cover one more major area. Connecting remotely.
Yeah.
Accessing these GNU Linux desktops when you're not sitting right in front of them. The need seems pretty obvious, right? Working from home, supporting users, managing servers.
Yeah, you can't always be physically there. So VNC, virtual network computing, that's a common one.
Yeah.
Widely supported, generally pretty easy to set up.
There's always a but with VNC, isn't there?
Slight chuckle. Yeah, the big one is security. VNC connections by default are not encrypted.
Right. Plain text. Bad.
Very bad, especially over the internet.
Yeah.
So it's absolutely critical, essential, that you tunnel VNC through SSH or use a VPN. You have to encrypt that traffic somehow.
Okay. What about RDP? Remote Desktop Protocol.
RDP is interesting. It's cross-platform, often gives you better performance than VNC, especially over slower links. Plus, it supports nice features like sharing your clipboard or redirecting local drives to the remote session. Same caveat, really. While RDP itself has encryption options, you still need to be very careful about securing it, especially if you're exposing it directly to the internet. Firewalls, strong passwords, maybe VPNs again.
Gotcha. Then there's Spicy. Never heard of that one as much.
Spicy. Simple protocol for independent computing environments. It's really designed with virtual machines in mind, often used with things like KDM-QEMU. It offers really high-performance features like good audio forwarding, smooth video, seamless USB redirection. It's generally optimized for use on local or private networks where you control the infrastructure, less common for remote access over the internet.
And finally, the old reliable SSH tunnels, secure shell.
Yeah, arguably the most fundamentally secure method because SSH itself is all about encryption. We're usually talking about X11 forwarding here.
How does that work?
It lets you run an individual graphical application on the remote machine, but have its window display on your local machine securely tunneled through SSH. It feels almost like the app is running locally. Very powerful for specific tasks.
So really, each of these remote methods has its place.
Definitely. They all have specific use cases, different performance characteristics, and really important security considerations. Mastering them means you can pick the best tool for the job, whether you're doing secure admin work, troubleshooting, or supporting users remotely.
Wow. Okay, so we've really covered a lot of ground today. You've taken this incredible journey with us right through the GNU Linux desktop. We started at the very bottom, the foundation, with display and multimedia systems, understanding Wayland and X11, the importance of PipeWire unifying audio and video.
Yeah, why those core bits are so essential to the experience you actually get.
Then we explored the different graphical homes, from GNOME's kind of predictable stability, perfect for enterprise,
to KDE Plasma's just boundless customization for the power users.
And even the lean efficiency you get with XFies and LXQT for older hardware or VMs, how to tailor that environment.
And then we dove into those really practical skills you need, using VMs as your safe sandbox.
Right, leveraging live media for troubleshooting when things go wrong.
Navigating that whole world of application management, traditional packages, Flatpak, Snap, App Image.
Understanding the trade-offs there. And we finished up with insights into customizing, hardening the desktop, and critically, how to securely access it from anywhere.
Yeah, covering the whole life cycle, really.
So this deep dive, hopefully, has really equipped you with some essential insights. Taking what can feel like a really complex, sometimes fragmented landscape of Linux desktop info.
And turning it into practical, usable knowledge. Something you can actually apply, whether you're just curious or you actually work with these systems every day.
It really is an ecosystem that embodies choice and power, isn't it?
It truly is. The flexibility is amazing.
So here's a final thought to leave you with. Given this really diverse, highly customizable nature of the GNU Linux desktop that we've talked about, How might that inherent flexibility not just adapt to, but actually drive the future of very specialized computing environments? Think beyond the standard desktop, maybe purpose-built home automation hubs, or even critical industrial control systems. Where could that flexibility take us?